Well, 200 years ago, James Duncan founded Massillon on the east bank of the Tuscarawas River because he thought that was going to be a valuable water resource. Little did he know that the aquifer beneath his town would be the real valuable, the truly valuable water resource in our area. Our speaker today, Mike Engel, is here to tell us about that aquifer and other interesting geology from Ohio. Many of you have already met him, and I am just thrilled to death that you're here. He's retired as Division Chief and State Geologist from the Geological Survey in 2021 after 37 years at the Ohio Department of Natural Resources to earn his degree, a BS and an MS in geology from the University of Akron. He specialized in glacial geology, and he attended Miami University as a PhD candidate with specialization in sedimentology. At the ODNR, Mike split his time between the Division of Geological Survey and the Groundwater Resources section of the Division of Water, focusing on glacial and aquifer mapping, aquifer protection, and Lake Erie geology. Mike now assists at the Geological Survey and works part-time at Egan & Associates in Columbus, a groundwater consulting firm that works with our very own Aqua Ohio to manage Massillon's public water supply. Please welcome Mike Engel.
Okay, well, thank you very much, Margie, for the introduction, and thank you folks for the invite. I'm excited to be here. I'm a Northeastern Ohio person, grew up in Akron. As we used to say in the old days, I was from LA or Lower Akron, or we could expand that to UCLA, Upper Canton, Lower Akron, and I would consider Massillon as part of Upper Canton, and McKinley is part of Lower Canton, so they don't count. Everyone. I'm sure your Massillon folks are okay with that. I understand there's been a little bit of rivalry with the two there for a little while, so all very good. Perfect. Yes, we're going to talk about the geology and aquifers. Can everybody hear me okay? Very good. And next of all, I do have a series of handouts, 2 maps and a pamphlet, and there's some up front, and there's also a number back by the water cooler, so feel free to grab some on your way out if you don't already have one. You know, I brought them up here, they're free, and I don't really want to take any back home, so if you have a grandkid or a neighbor or whoever might be interested, feel free to take one. So without any farther ado, we'll get started here. Basically, like she said, I work for Department of Natural Resources, and we have a piece of the local rock here on this picture, and we'll get into that, what we call that the Massillon sandstone, and I'll talk about that here a little bit more in a few minutes. I'll work my way to that. I'm going to be talking about bedrock geology, glacial geology, which is more of my specialty, and then also a little bit about the stream drainage, waters and wells, aquifers, because you can't really use the aquifer without water wells. And then I'll be talking about the aquifers around Massillon, and then the Massillon well field, which is run by Aqua Ohio. So we'll start a little bit broader, and then a couple of different topics, and we'll funnel it down to how you folks, when you turn on the faucet, where's that water coming from? So we'll try to take it in those bites. If any point there's a question, feel free to stop me. I'm perfectly fine with that, and just hold up your hand, or I'll try to keep an eye out for that or whatever. So very good. We're going to start back a little bit here. We're going to go through the history of Ohio, and Ohio looked very different. We're going to go way back to what we call the Pennsylvanian period. In the Pennsylvanian period, it was about 270 million years, 280 million years ago, maybe 290. And Ohio is a very different place. In fact, Ohio is right here, and this big chain of mountains here is what we call, basically now we call the Appalachian Mountains. This is what we were referring to as like the Appalachian or Allegheny type orogeny, and the Blues Ocean, Ohio's land, there was like a narrow sea just to the west of Ohio. And basically, right before this, the periods before this, the Mississippian down through like the Ordovician, Ohio was actually under the sea. There were this bayment here was much bigger. And by the Pennsylvanian, land started to creep in from these mountains here. And what was actually happening, now we know today how corporations and government agencies work. About every 10 years, all the corporations or government agencies come together. Then about 20 years later, they all split apart and they merge. Well, continents do the same thing. We call it plate tectonics. And the difference is they don't do it every 10 years. They do it like, every 300 million years, 400 million years. They come together and they tear apart. Well, basically, we were in a joining mood right at this point. And the joining, you had Europe and North Africa were bumping into North America. And when they had this collision, just like if you see two cars collide and all of a sudden that hood gets all crumpled and lifted up, well, that hood is what we call the Appalachian Mountains or the Allegheny Mountains. And right behind it was a basin, and that was like a little dip. So if you took like your bed mattress and you pushed it up, and then you had like that little sag behind it, that push up was the Appalachian Mountains, that sag behind it was the Appalachian Basin, and it filled up with sediment. Now we call that area Eastern Ohio, we call it Western Pennsylvania, West Virginia. That area there basically filled up with sediments. Then eventually as that pushing continued, those got pushed up into mountains. So basically the area just east of Ohio was fairly high mountains, maybe almost Rocky Mountain height, and all the sediment come off those mountains was washing or dropping down into what we call Eastern Ohio, and a little bit maybe even got out to Western Ohio. And another interesting thing is right through here, a little bit hard to see, there's a line going across. That's the equator. So we were right in the middle of the earth then, and the tectonics basically eventually pushed Ohio up to where it is now. It pushed us basically north and it pushed us west. And back then, we were down basically right where the equator is. So we were sort of in the tropics, but then the fact that these mountains were so high, much like you can have some fairly high mountains, snow-capped mountains in the Andes or Mount Kilimanjaro and that, these mountains may have been high enough to be snow-capped and have a little bit of ice melting on them during the summer, and all that water is washing these sediments down into Ohio. And this is the old bedrock map for Stark County. And basically Stark County, and basically Massillon's here, and this other little thing here is Canton. This base map, although this map was made in the 60s, this base map is from about 1904, 1905. And you see Massillon's a relatively small town, but it's really not that much smaller than this thing called Canton. And most of Canton's suburbs and stuff didn't even exist. You could almost probably count the number of houses between Canton and Massillon back around 1904. So basically things weren't quite as populated or urbanized back then. Basically we have this Pennsylvanian age rock. Here's a geologic column. As you go east in Ohio, as you go east and south, the rocks get younger. They get younger progressively as you go east in Ohio. And the older rocks are on top of the younger rocks. And basically, the older rocks in eastern Ohio are eroded away. And basically, the older rocks, the younger rocks now are on the top. And you have the older rocks here in the west. And these older rocks, and below these, you have rocks of the Mississippian age. And there's one Mississippian age unit that's pretty important in this area. We call it the Black Hand Sandstone. It's named after the Black Hand Gorge area in Licking County, east of Columbus. And the Black Hand Sandstone has an interesting nickname. It's called the Big Indian, or Big Indian Sandstone. And it's been an important aquifer across much of Ohio, much of central Ohio for a number of years. Still is used as an aquifer pretty readily. And it's also responsible for a lot of Ohio's scenic geology. And by that I mean if you want to see the Big Indian or Black Hand Sandstone, You can go to Mohican, Hocking Hills, Blackhand Gorge, Malabar Farms, almost any of those areas going from about, it basically runs from about roughly this area, like around Massillon, and you can find the Blackhand sandstone goes all the way down to, through the Hocking Hills, down almost to the Ohio River. So north-south it goes pretty far. East-west it's maybe only 30, 40 miles wide that we see at the ground surface, but it is an important aquifer. And one of the interesting units, we have the Sharon sandstone, which is sort of in Ohio, sort of like the base or bottom of what we call this Pennsylvanian age units, about 290, 280 million years old. Then one of the sandstones above it, we have a couple coals. Then we have what we call the Massillon sandstone. And the Massillon sandstone was named right in this area here because it was one of the predominant rocks in this area. And geologists named their geologic units after a town or geographic feature where it's really well exposed and well studied. So the Columbus limestone is in Columbus, the Delaware limestone is in Delaware, and the Massillon sandstone has been described and seen throughout the area around Massillon. And then basically we have other coals and stuff above it. And as you go eastward, you get into more coals. They start mining what they call like the number 5, number 6, number 7 coals. Basically also have names like Katanning, Freeport, that. So we get into the coal measures. So that was an important economic resource. The sandstones were more mining, basically more for aggregate, or sometimes they were mined for quartz, for glass manufacturing or abrasives. The modern geologic map, and I apologize, these colors are very close. Right here in the valley, basically underneath the Tuscarawas River, we have the Mississippian Cuyahoga Formation, the older unit, and then as you go higher in the landscape, you get younger rocks. As you figure the younger rocks are on top, which makes sense, and the deeper rocks are in the bottom, and basically the river cut down deep enough to get to the older rocks in the bottom of the valley. But you can't really see those rocks because they are covered with glacial sediments. They're covered with deposits that the glacial streams and stuff left behind. So basically older rocks in the valley, younger rocks in the uplands, and as you go to the east, the uplands get younger and younger in age. And by younger, I mean, they're only 270 million years old instead of 280 million years old. So for all of us people of our generation here, we're youngsters compared to how old these rocks are. Here's a couple pictures of the Massillon sandstone. I believe this is the Dundee Quarry down in basically Tuscarawas County. And here's just some other pictures of the Massillon sandstone. It's considered very coarse-grained. Again, this was formed by sediment coming off those mountains. The sediment basically filled came down like in a delta or river type system, and it was very coarse. You know, when we think of a delta, we think of the Mississippi Delta and the bayou, but you have to remember that Mississippi runs all the way from Minnesota down to Louisiana, and it's not like Minnesota has big mountains, so it's pretty gentle. So all the Mississippi's moving is like mud and silt, whereas this river, it only had to go from, say, like Pennsylvania, western Pennsylvania to Ohio. It was coming down very steep mountains, so the current was very strong, so it could carry all this coarse sand and gravel. And this coarse sand and gravel just settled out here, became rock, and that's what we call the Sharon sandstone and then the Massillon sandstone. I'm going to start talking a little bit more about the glacial part, because it's really important with the aquifers. And I'm more of a glacial geologist than a bedrock geologist. And basically, we had a lot of the ice forming. This is sort of a diagram showing the last glaciation. We had several in Ohio. We know we had an earlier one around 1 million years ago. We know we had one about 170 to 300,000 years ago. And the last one basically came through Ohio about 25,000 years ago, and it probably left this area about 18 or 19,000 years ago. So really, from a geologist's viewpoint, that was like yesterday. I know for us it seems longer, but for a geologist's viewpoint, 18 to 19,000 years ago was yesterday. And the fact that they got here about 26,000 years ago, spread out, and then by 18 or 19 they were starting to disappear. The last of the ice probably took out from Ashtabula County or Conneaut about 14,000 years ago. So it wasn't here all that long, but it pushed a lot in here. And some of the ice came from basically like the Georgian Bay and Lake Huron, and some of it came down the Lake Erie and basically came from like the Niagara Falls and Buffalo area. So ice left Buffalo and came here. I like to joke, how bad were the winters back then in Buffalo? The winters were so bad, even the glaciers left. So if you think even the glaciers are leaving because if the glaciers are leaving because it's too cold, you know the winters are bad in Buffalo then. So very good. So the glaciers came down Lake Erie, and then it started making a number of left turns. There was left turn only exits, and it was taking these left turn only exits one after another. And they tend to follow a major stream, and so we name these lobes after the major modern river that sort of lies on top. So we have a Grand River, a Killbuck, a Scioto, and a Miami lobe. So you had the big Lake Erie lobe, and it had 4 subdivisions. Some would argue, like my old college professor John Szabo at Akron, that there was a 5th one called the Cuyahoga lobe, but it didn't even make it all the way through Akron. So some people merge him with the Killbuck lobe. Some people say he's part of the Grand River lobe, but anyhow, there may have been a little one right here. And one of the interesting things is when you get, let's see here, need to read the fine print a little bit closer. We've got Ashland, here's Wayne County, here's Stark County. There's this little area here in Stark County. You're sort of between the Killbuck lobe and the Grand River lobe, and we call that the interlobate, the interlobe area. And what's important with that is you had all this ice up here by Kent and Ravenna and all that coming down into basically coming through like Hartville in that area, and all this melt water is melting off all that ice. Then you have this other lobe, this Killbuck lobe. You have all this ice coming through Medina and Wayne County, and all the water is coming off of that lobe when it starts melting. And all those lobes carry all this water down, and it's basically going to come down the Tuscarawas River, and all that sand and gravel is going to get deposited in the Tuscarawas River and its major tributaries like Chippewa and Sandy Creek and all that. So basically that is eventually going to become our aquifer, but we'll get to that in a few minutes. But I'm just giving you a little hint of the cool stuff that's coming. At least it's cool stuff to me, but I'm sort of a geology nerd. So, speaking of which, we have another geology nerd in the crowd there. We have a teacher, very good, who's an earth science teacher. In front of her, we've got Dr. Joe Hannibal. He was one of the curators and paleontologists at the Cleveland Museum of Natural History. So he knows a little bit about museums, and he knows a lot about geology. And the paleontology or fossil end, he knows way more than I do. I'm basically looking at the water, he's looking at the dead critters and plants. So it's very, very good. But at any rate, these lobes came into Ohio, and then this is the glacial Ohio map. I just love these glacial Ohio maps. And I have maps that show the whole state. And I was debating whether to start off with all these maps showing the whole state, but I figured I will get off track. I'll show too many slides. We'll run out of time. I'll have to run through the last 4 slides. I have to limit myself. So anyhow, here's Massillon. Here's Canton Moor over here. And basically, the greenish areas are sort of what we call glacial till. It's like a glacial clay or boulder clay. It's up on the higher ridges in that. And then basically right down the Tuscarawas River, then over in this area, we have what we call these buried valleys, which are important features. And we'll get into buried valleys here in a little while. And this is a slightly different map. This map shows what we call the features, and this shows things like moraines, which are ridges. It shows kames, which are little bumpy hills that the glacier left when the glaciers were melting. So this maps glacial features. The next one maps glacial deposit. And the reds are sort of gravel and the clay mixed. The greens are mostly the till or clay. And these oranges here are the really nice pure gravels over and through by Canton and down through Massillon that we end up using as aquifers. And again, we'll keep on this theme of gravels and aquifers as we go through this talk. But basically, most of these pink and orange areas, the aquifers are going to be gravel. There might be a lot of gravel or just a little bit of gravel. Most of these green areas, the clay is not a good aquifer, so the wells are going to end up going down into basically rock. Maybe that Sharon sandstone, or maybe that Big Engine, the older Mississippian sandstone. So you might end up with basically having a well in bedrock. Both are good. You typically can get more water out of sand and gravel than bedrock. You can get plenty in bedrock for your house or your farm, but if you want something for like a big factory or school or the city, you want like the sand and gravel type aquifers. This is the bedrock topography map, and if we stripped all this glacial stuff away, what would the bedrock surface look like? Well, you would have a steep valley. The greens are the valleys, so you would have a really big valley here by Massillon. You'd have another valley cutting across Canton. Then if you go farther east, there's a big valley over towards like Nimishillen and Louisville and Hartville and those areas. And the reddish areas are more your bedrock highs. And then this is the opposite. This is how thick the glacial drift is, and the pinks and blues here show your deep there. And you see basically this is actually a relatively narrow valley. When he settled Massillon, he put it right over the valley and right where this good sand and gravel is. And we have that some over here too by Canton. And the area in between's okay, but not as good. So I'm going to get into something now. How many of you have heard of the Taze River Valley before? You know, and especially folks in central and southern Ohio like to talk about the Taze River. There's actually a high school down there named Taze Valley. It's actually a high school for a feature, geologic feature, which is cool. And the geologic feature is even hidden, so it's named after something hidden, which is even more amazing. But this Taze Valley it started way down in what we now call the New River, basically Virginia, North Carolina, came up through West Virginia, came up here through Ohio, and then basically came through basically Indian Lake, then Grand Lake St. Mary's, cuts into Indiana and goes over towards Illinois. And right where we are here in Stark County, we were not part of the Taze River. There was a little upland divide, and we were part of what we called the Dover River. And the Dover River flowed north, and some maps call a river up here in the Lake Erie Basin the Aragon River. And here's a bit more of a close-up. The Dover River was actually flowing northward towards the Erie Basin. Well, let's think about it. Which way is the Tuscarawas River flowing now? It's flowing south. So this old valley, that river was actually flowing the opposite way, and it was flowing to the north because the Lake Erie was a basin way back before there was Lake Erie. It was a low area, it was a basin. There was shale rock there that had gotten scooped out, and it was a low area, so the river was flowing towards it. So it was flowing towards the north. It was perfectly happy. The Taze River was basically flowing north and west. It was very happy. Everything was flowing north. It was great. And that was because partly there's this big upland to the south that was part of all those Allegheny Mountains and stuff. So it's all flowing to the north. Everything's peachy keen. And then something happened. About 1 million years ago, this glacier, not the last glacier coming from Buffalo, but this older glacier comes down about through here somewhere, eventually maybe even farther south, but the rivers were running into that glacier coming in. They couldn't keep flowing to the north. There's a glacier there. The glacier basically acted like a dam, dammed up those north-flowing rivers, and formed a bunch of lakes, a series of lakes in different parts of Ohio. And eventually, the lake started to look for a new outlet, and we need, this water sort of needs to go somewhere, and they started cutting these new channels to the south. And when they cut these new channels to the south, because there was so much water, basically, they actually cut deeper than the old channels. So now the Dover River, we're going to call it the Newark, they were calling it the Newark River. Now it's going south, which is sort of the right way, but it's not quite going the right way. It's sort of following this path where eventually it cuts down, and it cuts down through Mount Vernon, and it cuts down to Newark, and then it basically cuts over from Newark, it cuts over and heads towards Columbus, and basically it's heading southward. So it's heading south, but it's going more southwest than southeast, and right now it's going more southeast. So it's starting to get the right idea where to go, but it's not quite yet there. It's going to need 2 or 3 more good glaciations and a little bit of uplift and things like that to get it going how it is now. But it's starting to get straightened out a little at this point. So it used to go north, now it's going south. I don't know how easy it is to see, but you see all these little blue dots all over. All these little blue dots are water wells. The groundwater resources section is now part of the Geologic Survey. They have over 53,400 water well records located for Stark County. Stark County is the #1 county for water wells in the state of Ohio. We have more water wells in Stark County than any other county. And a couple of the other top 10, Summit, Portage, Licking, Franklin, Montgomery, where Dayton is, most of them are areas that do have aquifers, and most of these are areas that are glaciated, and some of them are areas that have large population centers. Some of the large population centers, Cleveland's right on Lake Erie, they get water from there. Cincinnati is on the Ohio River, they get water out of the river. But some cities that get use strictly well water, Canton's one, Dayton's one, Massillon's one. Some others use impoundments and reservoirs. Akron's more of a reservoir city. So, but groundwater is very important. They have over 1 million water well records on file. We also have over 300,000 oil and gas well records on file there. So we have a lot of water wells, we have a lot of oil and gas wells. We also have mine maps showing the underground coal mines. And if you took of all of our underground coal mines in Ohio and put them together, it would be bigger than the state of Rhode Island. So there's a lot of underground data for Ohio. So here's like a little cartoon almost of a water well, and basically here shows one drilling through sand and it goes into gravel, and then when you pump it, you get what they call a cone of depression. This is the drawdown. If you basically want to try and experiment with it, stop at the 7-Eleven or Speedway, get a slushie, get a nice red or orange one where you can see it, start sucking on the straw. You'll see it go down around the straw and be a little bit higher on the edges. That's exactly what your water well is doing. And then this is one of the water well records or water well logs. And actually this is one of them, and for some reason it was all filled out, but some of that didn't translate to the slide for some reason. But at any rate, this is actually one of them for the city of Massillon. And we see it can go down, this one goes down to almost 100 feet, and it has a lot of sand and gravel, which is the good aquifer material. And how do we find most of this geologic information comes from drilling, either for water wells or test holes. Here's an example. Here's basically a water well drilled, and this is actually one of the drill rigs being used to drill a well here in Massillon. And then when they drill the material, they pull up, they take the samples. These are the actual samples here. And so you can see there's a lot of, it almost looks like play box sand, but it's a lot coarser. This is the sand and gravel that makes up your aquifer. This is what your drinking water is coming from. And basically, we'll take the sand and gravel and they'll run tests on the sand and gravel in a lab that'll tell you how coarse or how much fines or how pure the sand and gravel is, like particle size wise. This isn't anything about contamination. This is all the particle size and the natural properties of the gravel. And that'll help them set what they call a screen, and they'll attach this screen, which is basically a piece of well casing or pipe that has like little slots or filters on it. They'll set that down into your well, at the bottom of the well, then they'll extend that well into your aquifer, and then they put a pump in there, and that's what actually pulls your water supply. So there'll be pumps in these wells that'll actually pull the water out, and basically they treat the water and then they distribute it to the town. This is sort of a map of aquifer types. This orange is sand and gravel. Again, this is what we call a buried valley, and I'll show you that in the next slide. And then basically these areas here between the valleys, you have bedrock for the aquifer. You have maybe the Massillon sandstone, Sharon sandstone, or if the well goes deep enough, it might hit the Big Engine or Blackhand sandstone. Now, I use the term buried valley, and again, you have the valley here, and when we say a buried valley, basically what happens, here's the rock, here's basically a block diagram showing a valley. This valley was cut. Remember, we had those two older rivers. We had the Dover River going north, and then we had the Newark River going southwest, which went even deeper. Well, they carved this really deep valley. Then the last couple glaciers deposited all the sand and gravel from the melting ice. One of the things that's nice when you have ice melting and you're very close to that melting source, what happens, the clay and silt and the grit and mud, the real fine particles get washed farther downstream, and it's a lot harder to move the sand and gravel. That might only get a few miles or 5 or 10 or 15 miles from like the melting ice. So that sand and gravel gets deposited near to where the ice was, but there's enough water that it washes out that fine clay and grit and silt and stuff. So it leaves a fairly pure sand and gravel behind, which makes the best aquifer material. And people tend to associate buried valleys with this. Now, there's other areas. I was just working by Licking County, and there's a buried valley here that was cut. It's almost 400 foot deep, and it's completely filled with clay. The glaciers just ground up a lot of shale and deposited clay there. So that buried valley is full of clay, but you're lucky the one here by Massillon is full of sand and gravel that makes for the great aquifer you folks have here. So this is basically a sand and gravel aquifers map. These gray areas show where, if you have a good well, you can get over 500 gallons a minute from a good well. Whereas if you get in areas like this, you're going to probably be limited to like about 25, maybe 50 gallons a minute's the best you're going to do. So that's plenty good. Even 5 gallons a minute is adequate for a household. 10 or 15 might be good for like a farm, but if you want to have water supply in a city, a factory, or high school or something, you really, in this area, you really need to be near one of these buried valley type systems. This map here, basically, this shows roughly what you would call the potentiometric surface, which is a fancy word for water table map, more or less. It's not exactly the water table, but basically the highs are in the uplands and they flow towards the rivers. So a lot of the regional water is basically flowing from even the rock aquifers, but there's basically water is being funneled towards the Tuscarawas River in the valley here, which is good because that helps the water supply coming towards the aquifer. And the next one, this shows aquifer recharge. And this area here, it's not that big of an area overall, so the rainfall over Massillon is going to be about the same as the rainfall in Canton. And sure, over the course of a year, sure, you're going to get that one Tuesday where, oh, it's raining here at my house in Massillon, it didn't rain a drop at my son's place in Canton. But for the most part, over the course of the year, you know, the rainfall's about equal. But here where these valleys are, the recharge is really high. It's like 7 to 10, it's fairly high recharge here. It's basically like 7 to 10 inches a year, where in these areas it's like 2 to 4 inches a year. The difference is it's flat, it's sandy, it absorbs the water real easy, the water table's low, it's close to the ground surface. The water can get to the water table pretty quick. Where up here it's hilly, there's clay at the ground surface, so the water wants to run off, and basically it doesn't absorb, and then the rock doesn't take water as quick as the sand and gravel will. So basically, the aquifers here are getting some water recharge, but not like the valleys. And the recharge in the valley is good because it helps keeps the wells supplied. The bad side about that is if you have a spill or a truck rolls over, or you have a spill from a factory or something, it gets to the aquifer fairly quick, so that can be a problem. So it's good for replenishing your aquifer. It's bad if you're worried about contaminating an aquifer. So it has a good point, and it has a bad point, and geologists have to keep track of both the good and the bad points. And now I've got a couple slides from Egan and Associates. They've worked with Aqua Ohio on the Massillon well field for a number of years, and we work with Aqua Ohio. Aqua Ohio's got a couple of they maintain a lot of different water supplies in the state. They do Massillon, Marion, Mansfield. They do some of the suburbs of Columbus and Dayton. They don't do the real big cities. They don't do like Dayton level cities and things like that. It's more like suburbs and medium to smaller sized towns is what they tend to specialize in. But actually Massillon's got 3 or 4 different well fields here. Basically, these are each areas where they have a concentration. They have what they call Riverside, Middle, Lake Avenue, and then down here is the water treatment. So basically strung along this river, they've got at least 3 different areas that they're pulling water from. You don't want to get too many wells in just one area, because then you've got sort of you're robbing Peter to pay Paul. Basically, the wells will start pulling water away from each other. And it's also good to have backup like this, so if there's ever a problem in one area, you have other wells that can fill in, and then they can help distribute it through across the whole city and their service area. Again, we got this, this was obtained from Egan, who does the work there. All the other slides came basically from materials at the Department of Natural Resources. I don't know how well you can see these squiggly little lines, but I think you might remember that the valley is pretty narrow coming through here. So basically, if you come up here, these are the ridge tops, you have the bedrock. That's not the aquifer you need, so you have to stay in these really narrow little valley areas through this area that are basically right underneath the Tuscarawas River and the floodplain of the Tuscarawas River. And that makes it a little bit difficult when you're siting a well. There's not a lot of extra area. The EPA has all sort of rules how far away you have to be from different wells or from factories and things. So it really restricts a little bit where you can put wells in this area. So I think they've done a very good job of splitting their wells between these 3 areas where they're pumping the water from. And this is what we call a cross section. This is basically, geologists will take the water well data, and then they'll sort of connect the dots on the well records. So this through here is almost all sand and gravel. then below this dashed line, it starts getting a little bit more silty and a little bit finer grain. So this is, if you go too deep in this, it's not as good as an aquifer as the shallower. Maybe this finer stuff, some of it might have even been some of the stream sediment from some of those older streams that we taught, stream systems, because this is down, oh boy, this is down well below 100 foot deep. So it's better to have something a little bit shallower and stay in this zone. And basically you have like the middle well field and the other well fields are showing this. And so they're all pumping water from basically the same aquifer. It's just they're enough of a distance apart where they're not interfering with each other, and they're also not enough distance apart where, you know, you need some distance between them as far as zoning and working them in between all the other things going on here. And also, one of the important things too about aquifers is the sand and gravel is very good. And someone else likes sand and gravel a lot, and that's basically the aggregate or mining industry. And they often need to go to about the same place that the aquifers are at. So sometimes it's tricky. They might mine an area nearby, where there's basically water wells pumping water in that. So sometimes we have to work out agreements or different things to basically have it. So how many of you driving today saw an orange barrel somewhere? Like all of us, right? Because there's construction, road or building going on everywhere in Ohio. Ohio's blessed with a lot of aggregate. Western Ohio uses limestone. Eastern Ohio uses sand and gravel. And so basically, so besides being an aquifer, it's an important source of building materials in that. So I will feel free here to, I've got a little bit of time for some questions, and I can hang around a little bit afterwards. And again, I've got the maps in the front, the maps in the back. There's a gentleman there with a white ball cap. He has a question.
You may have said it or I missed it. What is the average depth of the Massillon well field?
The average depth here. Well, let's go back here one. I know it's a little bit read to see. Most of these wells, the screened interval, the ground surface varies a lot, but it looks like it's about 950 feet. And then the wells are at, these little marks here show like the part of the well they're actually using. They're between 800 and 840. So if you subtract that from 950, they're probably about 150 feet, give or take a little bit. And then the one,
They couldn't hear that in the back.
oh, I'm sorry. It was about 140, 150 feet deep. And then the one water well record, come here. Yeah, okay. It is showing sand and gravel from about 90 feet to 200 feet. And I think they set it at like around 150 to 180. So really, there's good aquifer material running from, oh boy, probably, realistically here, probably 50 feet to 200. You've got 150 feet you can use for aquifer, which is really good. We're working with this small town by St. Clairsville and Bel Air on the Ohio River, right across from Wheeling, West Virginia. And their aquifer there is 30 feet deep, 30 feet wide. And I mean, you drill to about 100, and it's 100 feet to 130 feet. There's nothing above it. There's nothing below it. The floodplain there is basically a half-mile wide, and they've got factories all around it. And they want a new well, and we literally cannot find a place to put in a new well for them. So basically, you folks are in pretty good shape here. Aqua Ohio helps manage it well. They get information from the state. Egan helps them. So you folks are in pretty good shape here in town. Yes, sir.
In my Boy Scout days, one of the employees from Republic Steel told us that they were able to draw water from the Big Indian, which was the Dover, a different name, and they were able to run the steel mills during World War II at maximum capacity because of the abundance of water. And also, at their capacity, they did not lower the water level in the aquifer. Was that correct?
Yes, that's a pretty accurate assessment there. They do have a number of the buried valley systems also extend over towards Canton and that. So yeah, that's good. And you basically have a very good, back in the 40s and 50s, they used groundwater and wells to supply the rubber factories there in the south side of Akron. Firestone, Goodyear, Goodrich, they all used water wells. Now, eventually, they switched over to surface water, and now the rubber factories have basically disappeared. But those aquifers here were very, very strong aquifers, both in the Akron, Canton area and Massillon. So this area is blessed, and this really was one of the first areas in Ohio studied for groundwater, is the whole Akron, Canton area, because the good aquifers were a good place to put industry. When we had much more of a manufacturing-based industry, it was perfect for the steel and rubber industries, mills, paper mills. Dayton area, you've got the Scales, General Motors. Dayton area also had very good groundwater, so it was a very good source of water for industry also. So a lot of Ohio's industry was really based on this availability of water. And then we also had a lot of coal. They burned coal for heating and energy back then. We were a big source of iron ore. In fact, during the Civil War, we provided a lot of the iron to make the cannonballs and cannons and ironclads, and we basically depleted out our iron through the 1850s, 60s, and 70s. And so it's hard to think, and we didn't have the type of iron deposits you have like in Minnesota and that. We had a little bit more of a lower grade iron, but we still have a lot of, you can find remnants of iron furnaces down by the Ohio River, like in Lawrence and Vinton County and that. So Ohio was very much a mineral-rich state, still is, and we're also very much a water-rich state, still are. And so those two things have really helped Ohio's economy, over its 200-year history here. Yes,
One
sir.
more.
I was always told years ago that this big Indian, does it actually flow? I'm told it flows north into Lake Erie. Is that right or not?
Well, a couple things. Right now, basically, groundwater typically roughly follows, but not exactly, the surface divides. And we know the Lake Erie Basin and the Ohio River Basin, basically, the water basically flows towards them, and there is a divide. And the divide runs through Medina County, and it runs through basically the middle of Akron. And right now, basically, most of the groundwater and most of the surface water is roughly going to be going southwards. Now, in the past, it did go northwards. Now it's basically is basically roughly heading southwards. The groundwater in this area is typically flows towards the surface water, so most of the water locally is basically going towards the Tuscarawas River Valley, right in this Massillon area. It flows into Chippewa Creek. If you go north of Chippewa Creek, it'll start flowing up towards northern Medina County. It'll flow towards like the Black River, Vermilion River, Rocky River. It flows up towards Lake Erie, but south of Medina County, it flows into Chippewa Creek. Everything in Wayne County is flowing basically southwards into either Chippewa Creek or Killbuck Creek. So some of those switched over time. If you're referring to the old Dover River as the Black Big Engine, yeah, that did flow north. The bedrock typically doesn't, in Ohio, typically is sort of regional, but doesn't have like a real major flow direction like some of the aquifers out in the Great Plains do.
Do we have a sense of how fast that water is flowing in the aquifer on Massillon?
It doesn't really flow all that fast. I mean, we have we do have what we call a hydraulic conductivity, which is a measure of feet per day, and we'll say like a good aquifer is maybe flowing 50 or 100 feet per day, but that part of that is a vertical component, and part of that is a horizontal component. The vertical component, because of gravity, is probably going to be stronger than the horizontal component. But I mean, it's safe to say it's in feet today. A really good gravel, a really coarse gravel, you might start getting in the 200, 300 feet per day range. What we call a limestone, if it's got karst or solution, might even do a little better than that. But then again, you get like a shale or clay, then they start measuring that in like centimeters per day because it's not moving very good. So if you see something that's flowing centimeters per day, that's the other half. Egan also works with landfills. So, okay, you want a landfill that's all clay and shale and the water's moving centimeters per week. You want a well field that's sand and gravel or limestone and the water's moving feet per day. So, two completely different needs in that. So, thank you all for coming.